So part A, what are the vertical asymptotes for the graph of f of x equals? So here's a rational function. We have a polynomial divided by a polynomial. It's a ratio of two polynomials. Vertical asymptotes, let's just make a side note over here. Vertical asymptotes occur at the x values where the function is undefined. And we just talked a minute ago about what makes a function undefined. Well, when you have a fraction, if you are dividing by 0, your function is undefined. So our vertical asymptotes will occur at the x values that will make your denominator equal to 0. So when you have to find vertical asymptotes of a rational function, you say, well, I'm going to take my denominator. That should be a 12 at the end right there. X squared plus 7x plus 12, and I'm going to set it equal to 0 and solve for x. All right, so solving for x here, because it's an x squared, we have to change our solving methods. It's not a linear function. We can't just get x alone. We're going to think factoring first. This is x squared, so it's a trinomial. Are there factors of 12 that add up to 7? And there are, 3 and 4. We would say x plus 3, x plus 4 equals 0. Let's set each of those factors equal to 0 and solve. And then over here we get x is a positive 3 and x is a positive 4. So this particular graph would have two vertical asymptotes. I will abbreviate that with VA. One at x equals 3, that's a vertical line at x equals 3, and this is a vertical line at x equals 4. All right, so how do we determine horizontal asymptotes of our rational functions? So part B, what are the horizontal asymptotes for the graph of this function? Well, let's take a look at a few cases and then we'll come back and answer this question. Case number 1, the degree of the numerator is less than the degree of the denominator. So let me give you an example of what that could look like. Let's say we have function g of x. So this is just an example. It's not the one we're trying to solve up there. If we have the polynomial x plus 4 divided by the polynomial x squared plus 1, we want to identify the degree of the numerator and the degree of the denominator. So the degree of the numerator is 1, because that's an x to the first power. The degree of the denominator is 2. So when the degree of the numerator is less than the degree of the denominator, so the denominator will have the bigger degree, we have an automatic horizontal asymptote at y equal to 0 every time. All right, so that's one case. Case number 2, what if the degree of the numerator is greater than the degree of the denominator? So if it's kind of opposite of what we just did. So let's look at an example just to see it instead of just read it. So if our function h of x is x squared plus 1 divided by x plus 2. Let's identify the degree of the numerator. That has a degree of 2. And then the degree of the denominator is 1. If the degree of the numerator is bigger, then there is no horizontal asymptote. All right, case number 3. What if the degree of the numerator and the denominator are the same? So, for example, if we have our function k of x equal to, so here's our numerator, 2x squared plus x plus 1 divided by x squared minus 1. So the degree of the numerator is 2. The degree of the denominator is 2. So when the degrees are the same, what we do is we take the ratio of our leading terms. So the leading term in the numerator is 2x squared. We're going to create a ratio. We're going to put it over the leading term of the denominator, x squared. There we go. And then we're going to simplify this. 2x squared over x squared. we notice that those x squareds would cancel away, leaving us with a 2. So our horizontal asymptote is always going to be a y equals, by the way, because it's a horizontal line, and it's going to be y equals 2. All right, now that we have our 3 cases, let's go back up to part B. What are the horizontal asymptotes for the graph of f of x equals 3x minus 2 divided by x squared plus 7x plus 12? So you just saw it all came down to the degrees of the numerator and denominator. So this degree is 1, it's x to the first power. The degree in the denominator is a 2. So if the degree on the denominator is bigger, that is this case number 1, it's an automatic y equals 0 for our horizontal asymptote.